Hi there, and welcome to this talk titled Indexing and Searching NuGet.org with Azure Functions and Search. In this talk, I will guide you through a solution that we've been building at JetBrains, which is doing essentially what the title of this talk says, namely Indexing and Searching NuGet.org with Azure Functions and Search. I'm Maarten Balliauw, I work at JetBrains, and let's dive in. In ReSharper and Rider, we have this functionality called Find This Type on NuGet.org. What it does is it searches for namespaces and types that you did not yet reference in your project. So for example, if you're writing JSON convert as a type in your editor and you don't have a reference to Newtonsoft.json yet, what this will do is a quick fix will pop up, and that quick fix offers you to find this type on NuGet.org. So if you invoke it on JSON convert, it will reach out to an API that we have, search for JSON convert and which packages contain that type, and then offer you to install Newtonsoft.json, and then you can continue coding happily after that. This functionality was introduced in ReSharper 9 in 2015, and it consists of course, the ReSharper functionality, where we have that quick fix in ReSharper, where we have the integration to recognize that a type is not found or referenced yet, and so on. So all of that is in ReSharper, but it also needs an API on the other sides. That API will offer, of course, a web API where we can query for a type or namespace and get back the package names, but also it will need to index NuGet.org. So what it does, or the way it's set up currently, is that it is a cloud service on Azure, and cloud service as in the cloud service project type, where you have web and worker roles. We have a web role that serves the API, and we have a worker role doing the indexing on the background. Back then in 2015, this was the way to build your cloud applications on Azure, so that's what is still running there right now. The indexer that we have running in that worker role is using the NuGet OData feeds. OData is essentially, I would say, something similar to how GraphQL works, but slightly different as well. What it offers you is that you can write your query in a URL and then get back all of the results in the shape and formats that you want. So let's have a look at the URL that we have on the slides here. If we would open that one in our browser, you would see a bunch of XML contents. If you look at the URL, you will see that we are selecting from the NuGet API only some fields of the packages that are on there. We are sorting them by last edited timestamp, and we are filtering them to say we want the last edited timestamp to be somewhere later than today. This is interesting because it allows us to query incrementally and index incrementally. If we run this indexer, for example, every 5 minutes, what we could do is change that filter to be 5 minutes ago, and then we would get the packages from the last 5 minutes. The data that we get back is XML based, but whatever is in there is the package ID. That's in there. The package version is in there as well. If there's an author known, the author will be in there as well. And we will get back a link to the actual package that we can download, open up, and see what is in there to index all of the assemblies that are available in this package. Another thing that is in there is that the OData feed is paged per 100 results. This means that if there's more than 100 results, we will have to follow the link that says I'm the next page, and that link will essentially be exactly the same thing that we had before, but this time adding a skip parameter that says fetch me the next 100 results, and so on and so on. Now, this is all nice, but the problem with it is that it's also kind of slow. First page is always nice and fast, but if you go to the 10th page or the 20th page or even beyond that, it starts to get a little bit slower to query all of that data. Now, NuGet has been growing over time. In 2018, my colleague Alexander checked the NuGet.org repo and the packages that we indexed, and back then NuGet.org was close to 2 terabytes of data. I checked it last week, and right now it's close to 3.5 terabytes of data, so it's really growing fast, NuGet.org. So NuGet is growing, and that means that essentially that API may also get slower if you would have to fetch a lot of pages from it. Also, the OData feed is going to be deprecated. I don't know when, but it's going to happen at some point. So essentially, we would have to move from that API to another API to see whether we can continue querying and indexing everything that is on NuGet.org. Before we dive into functions, let's talk a little bit about the NuGet server-side API, because that's going to matter in the solution that we are building in Azure Functions. So we've already seen that there was that v2 OData API or protocol that is available on NuGet.org. There's also a v3 protocol, and that's the recommended way of doing things on NuGet. The v3 protocol is JSON-based. And if you go to api.nuget.org/v3/index.json, you will get back a JSON-based list of resources that are available. Those resources in there are really separate APIs that serve a different purpose. So for example, there's a catalog resource in there, and the catalog is an append-only event log of everything that happened on NuGet.org since the beginning of time. So all of the package additions, package deletes, and so on will be on there chronologically, so we can basically cycle through that if we were to index NuGet.org. There's registrations, and registrations are the current state of a specific package. If you use Rider or Visual Studio, and you query NuGet packages and you get the package details, very often these things will come from the registration blobs that are there, so from the registration resource. There's a flat container in there as well, and the flat container is used during package restore. Essentially, when you're restoring packages in your project and solution, you don't want to hit search because you already know which package ID and version you want to restore. So the flat container is a convention-based URL that allows you to fetch the binary for a certain package. There's some other stuff in there as well. Search is in there, everything is in there. But the one that's really interesting for our use case here is the catalog. Since the catalog is an append-only stream of mutations on NuGet.org, it means that we get to cycle through it chronologically. So if we were to fetch packages from the last 1 hour, we could do that using this catalog, because we can set our cursor there to 1 hour ago, and we can continue where we left off. And once we reach the current timestamp, we can stop indexing, maybe in 1 hour start again, and again continue where we left off, which is the current timestamp. The catalog has a very simple structure. It has the root page, and the root page simply contains a list of all the pages that are available in the catalog. Every page itself then contains catalog leaves, and every leaf itself has package details and what has happened to that package. Now I know this is fairly abstract, so let's visualize this a little bit and let's have a look at the NuGet.org catalog. Right, if we go to our browser and we go to api.nuget.org/v3/index.json, you will get back this NuGet.org API v3. And what is in there is resources of a given type. So there's a search query service here, there's an autocomplete service, and you get the endpoints as well. So if you want to query or autocomplete packages on NuGet.org, you can use those URLs and start working with that. The one that we are interested in though is the catalog. So let's search for catalog, and we will find that there's a catalog URL that we can follow. So let's go there. And what you will see in that catalog is, like I mentioned, it's that first page that contains a list of all the pages that are available. But the way it is structured is that you get a commit ID, which is an identifier that can be useful in whatever you are doing. There's a commit timestamp as well. When was this specific page added to the catalog? There's the count of packages that was added to the catalog at this time. And there's the page itself that you can follow to see what is happening there. So I'm just going to open a random page here, and let's go in there. And what you will see is that this page contains all of the packages that have been added at this timestamp, which is 12th of July in 2019. There's 548 packages in there, and every package has an ID, which is again a link to another resource with package details. It has the package ID as well and the package version. And there's again that timestamp. So again, if we want to fetch packages from the last 1 hour, we could, for example, ignore this one safely because this timestamp is not within the last 1 hour. The type here is important because that is going to describe what was happening to that package. Package details means the package was added or updated, and we can get information of that package. If we follow this link, you will see that there's authors in there, there's the description of the package, the ID, license URL, all of the details that you would typically see inside of Visual Studio or Rider. and that you would typically consume as a consumer of the NuGet package. In our case, what we are really interested in for our indexing functionality is the package IDs, package versions, and where can we find the binary so that we can open it up and see which assemblies are in there and which public types and namespaces are in there. Right, this of course is all JSON based, and this is basically following around some URLs. The cool thing is that the NuGet team also created a package called nuget.protocol.catalog, and I downloaded the sources for this because I wanted to use it in my project and make a few small changes to make it a little bit faster for this use case. But essentially, there's a nuget.protocol.catalog package that you can use. And what it does is it allows you to traverse the catalog like I just did in the browser, but then programmatically. The way it works is like this. You will need an HTTP client, you will need a cursor, and that cursor will basically be the pointer to where you are in that entire catalog and which timestamps you want to consume. So for example, if we set this cursor to datetime offset.utc now, and I should do it there, add hours -2, we will get the packages that have been added in the latest 2 hours on NuGet. Once you have those two things, you can create a catalog processor that uses that cursor, that uses a catalog client with that HTTP client. And what it does is it will call you back whenever it encounters either a package addition or a package deletion. And what we can do if a package is added, well, we can print it to console or do something with it and basically enjoy it and see whatever is happening. So if we run this one, we should get the packages from the last 2 hours being printed to the console. And as you can see, this will happen at some point. It takes a little bit of time to basically fetch that entire first page and get all of the details that are there. But once we have that, it's really fast to traverse this catalog. So if you did not know, today, the 6th of April, moody.worldinfo version 1.0 was added to the NuGet.org catalog. So if there was anything you wanted to learn from this talk, this is probably not it, but still, there you go. Right, so we can use C# code to quickly traverse through our catalog if we want, and that's very nice and probably something that we can use for later on. Back to slides. Find this type on NuGet.org in ReSharper and Rider. Currently is using that OData API. So ideally, we should be moving it to using the v3 API. That's mostly done. In fact, I think it's already running on that v3 API, or it's going to happen very soon. The only thing is that it's still missing download counts in the API in NuGet.org. There's an issue for that. I hope it gets added at some point, because ideally, if we have search, we also want to have package download counts to provide a little bit of relevance in searching what is available on NuGet.org. And if you search for JSON objects, or JObject, you probably want to have Newtonsoft.json with a higher download count than the package that I may be uploading using the same type name, right? So we could refactor the existing one, or we could build a new version using new techniques and so on, and that's going to be the remainder of this talk. Right, building a new version. What do we need? We need something that watches this NuGet.org catalog for package changes. We need something that for every package change downloads the package, scans the assemblies that are in there, and stores somewhere the relationship between package ID and version, and namespace and public type from the assemblies that are in there. And then of course we would need an API that is compatible with ReSharper and Rider, even version 9, because we don't want to break existing clients, so we essentially would have to make it possible for people to consume this one very easily using the same API. Watching that NuGet.org catalog could be a periodic check. We could run a timer, for example, every 15 minutes and check which changes are there and then start indexing things. For every package that was added, we could add it to a queue and then run that check for every package change to break open the package, see what is in there and index what is in there. And then the API itself could be anything. It could be web API, could be a function, could be whatever you want, as long as it serves up JSON results and has the same signature that we use currently in ReSharper and Rider. It kind of sounds like functions. We could create a watch function, which is invoked periodically, for example, watches the catalog, then pushes everything into a queue. From that queue, we can start indexing what is in there. That indexing could push everything into a search index, and then we could use that search index to find type on in ReSharper and Rider. So that's kind of like functions and a nice flow that we could build in functions. And that's what we did. So let's look at how this works. First of all, we want to collect from the catalog again. So I already had this console application that fetches data from the catalog. Well, what I could do is create a new timer trigger function. Let's call it collector function. And what we can do in here is essentially run that exact same code. So what we could do is write some code in there that does this. Let's resolve all of the references there. Yep, there we go. And I think I named this timer instead of my timer. So let's do that as well. So essentially, this is what we have. We now have a function, and I even misspelled the name. So let me quickly refactor that and make it proper. So let me make that collector function. And this would be nice as a name of as well. Anyway, I'm doing way too many things for this demo, but you get the idea. We now have a timer function. In the timer function, what we will do is essentially the same thing that we did in that console application. We will create an HTTP client, we will use an in-memory cursor, and we will then run that catalog processor and start collecting things every 5 minutes, I think this cron job is expressing. So the nice thing about a timer function in Azure Functions is that you get an object called timer, in this case, that is a timer info type, and timer info has the last time it ran. So remember when that catalog is chronological and we can use a time-based cursor to traverse through it? Well, if we have the timer info and we have the last time this timer ran, we already have our lower bound of the entire period of time that we want to scan on that catalog. So that's kind of interesting. If not, I'm just going to play safe and only fetch the last 2 hours from the catalog. And if we have this one, we can start running it. So let's do this. Let's run our collector function. And this will now run as an Azure function that is invoked every 5 minutes. By the way, this is a timer function, and it's kind of annoying that for timer functions, you always have to change the cron schedule if you want to invoke it. I'm going to quickly show you how you can invoke this one without having to change that expression. So if you're using timer functions, there's actually a way to invoke it using an HTTP client. And what you can do is invoke it using the management or the administrative endpoints. So your functions host will always expose all its functions under /admin/functions and then the name of the function. And then you can invoke it from there. So I can invoke it from here, run it, and you will see that our function is returning a 202 accepted. Our function is now running. And if we look at this, we get back, well, at least the fact that it's being run, but something is wrong there. But anyway, you get the idea. This is how it should work, and this is what should be happening. Let's, for the sake of this demo, assume that I did not have an issue in this function and everything worked fine. This would run, and in our code here, we could push messages into a queue and start indexing all of those things. Not really important, because I'm going to throw this away for a greater reason. The greater reason is the best practices in building serverless applications. If anyone knows Paul D. Johnson is the person who has been building AWS Lambda, and he's been blogging a lot about building microservices and functions and Lambda-based architectures. And in one of his blog posts, he mentions a number of best practices. And an interesting one there is that every function should only do one thing and only one thing well. This makes it easier to handle errors that may occur and also to scale a function. If you have a function that does 5 things, it's much more difficult to figure out which of the 5 things failed if the function fails. And if you want to scale just one step of those 5 steps, it's also much more difficult if they're all embedded in one function. If you would use 5 different functions and have messaging and queues to communicate between them and invoke the next one in the pipeline, it's actually better because you can scale it out separately. And if one part of the flow of the pipeline flow that you have is under stress or needs more instances, you can simply scale up that one. If something fails, you can really figure out quickly which one fails and so on. In Azure Functions, doing all these things can be done using bindings. There's a bunch of default bindings available in Azure Functions. For example, there's that timer trigger binding that we just used. There's an HTTP binding that you can use to invoke a function over HTTP. There's a blob trigger that will invoke whenever a blob is created somewhere in storage. There's a queue trigger, etc., etc. There are essentially 3 types of bindings available in functions: trigger bindings, input bindings, and output bindings. Trigger bindings will be doing what the name implies. They trigger your function. They check for data, they check for incoming messages, they check for whatever, a timer, for example, for the current timestamp. And when they see it's time to run, they will invoke your function and pass data into that function that it can use to do something with. There's input bindings as well. Input bindings don't trigger your function, but they can provide an additional data type to work with in your function. So for example, if you have a timer trigger, you can also create a blob input binding to get a reference to a blob storage where you want to write some contents, for example. There's also an output binding that you can use. Same thing, it doesn't invoke, it doesn't trigger your function, but it can be used to write output from your function into some other place. The cool thing is, if you use, for example, those output bindings, your function does not need to have all of the boilerplate code to set everything up. No, instead it just gets a reference to something where you can write the output to. You write the output and then the function's runtime will handle and take care of the fact that you provided output and it has to be stored somewhere. So doing that, our function can easily do one thing and one thing well, because it no longer has to work with setting up everything that is related to, for example, writing something to blob storage. Now, there's a bunch of trigger input and output bindings out of the box in Azure Functions. Ideally, for us, we would like to have a NuGet catalog trigger. Because we are watching that catalog. Essentially, what we want to do is have a function that is invoked when a new package is available on NuGet.org, and then just work with that package instead of having to write all of this processor code. Well, turns out there's none of that in the Azure Functions runtime, but the cool thing is that we can build our own bindings. There's a couple of examples for other scenarios out there. There's a SQL Server binding that I came across. There's a Dropbox binding that I came across. But in our case, we can write a NuGet catalog binding. Now, our NuGet catalog binding is going to be a trigger binding, because when a package is available, we want our function to be triggered, and custom triggers are not officially supported in Azure Functions. The reason for that is that for a custom trigger to work, you have to have reserved capacity. So if you're using pay-per-use consumption-based functions, this will not work because your functions only run when they get invoked. But if you have a custom trigger, you have to have some process running all of the time to trigger your functions. And that's why you need a reserved instance, and that's also why it's not officially supported yet. We have been using it in production for a long time now. Well, a long time being 1.5 years. And it works perfectly. It only crashed a couple of times, which was probably because of some upgrades going on in Azure. It actually works as long as you have a reserved instance. So let's do this. Let's create a custom trigger binding for the NuGet catalog. Right. So in our code, the last thing we want to have is this collector function to run. So let's remove that one, because that's not what we want to do. Instead of having all of this boilerplate code that does all of these things, we want to have a very simple function that looks much nicer and is essentially going to be something like this, where we have a function that runs, we decorate it with a NuGet catalog trigger, and we get a package operation from that trigger. And then we can add it to a queue and do whatever we want with it, but no longer all of that boilerplate code to check the NuGet.org catalog. Our trigger here will need 2 parameters, or at least one for sure, which is a cursor blob name. Before, I was using the timer or abusing the timer to get that cursor to traverse the catalog. Of course, if we have a custom binding, we still want to store somewhere where we stopped indexing the catalog and where we can continue if we run it next. So what we want to do is store this one on storage somewhere. So that's going to be our cursor blob name. And if I would look at my storage account here, what you will see is that on this production one I have here, there is going to be that blob, and that blob is just going to contain a timestamp of where I left off in running this entire function. Right, our function itself is going to be very simple. It's going to index or add the package that we just received from our trigger and store it somewhere. So the function is not that interesting. So let's dive into our catalog. Our NuGet catalog trigger is a very simple attribute that we decorate our function with, or at least a parameter to our function with. And what it's going to hold is all of the data or configuration values that are required to do something there. So for our NuGet catalog trigger to work, we will need a service index URL. Where is the API that we want to fetch the catalog from? A couple of other options that I added for testing. So for example, I can add a test where I say only get the latest 2 hours from the catalog and not everything since the beginning. A cursor container, where are we going to store that timestamp blob in storage, and a cursor blob name. Now, obviously, this attribute doesn't do a lot. It only contains those properties in that configuration. So we have to now set up Azure Functions to make use and to recognize this as being a trigger binding. First thing we need to do is annotate this one with a binding attribute, which tells the Azure Functions runtime that this NuGet catalog trigger attribute resembles or is in fact a binding. Once we have that, we can start configuring it. So Azure Functions will recognize this as a binding attribute, or this is a binding in functions, but it doesn't yet know what to do with it because it only contains those configuration values, right? So what we have to do is also create a configuration. We have to create an iExtension config provider. We are extending the configuration of Azure Functions. Our extension has the name NuGet catalog. And in our extension, we are going to configure what our attribute means. So what we are going to say is NuGet or functions runtime. Whenever you encounter this NuGet catalog trigger attribute, I want you to treat it as a binding. And I want you to bind it to a trigger called trigger binding provider of type NuGet catalog trigger attribute binding provider. Very long names, I know, but there's, I have this convention of naming those things the same as my extension is named. So that's why you will see all of those things pop up and have a very long name everywhere. Anyway, this configuration will tell the Azure Functions runtime how to treat that NuGet catalog trigger attributes and what to do with it. And we're saying it's a trigger binding, do something with it. This is not enough yet. What we also have to do is create a startup class, much like in ASP.NET Core, where we say that in our configuration for functions, we are adding our extension as well. And we are saying, look, this extension that we just wrote, add it to the web jobs builder so that functions can build it and make use of it. Right. Our trigger attribute binding provider itself is where our binding starts to work. What this one is going to do is do the initial setup of what we are passing in from our binding. So what this one will do is it will make use of a name resolver, an account provider, and a logging factory to try and create a context for our trigger binding. So what it will do is it will check the parameter. If it's a NuGet catalog trigger attribute, which should always be the case, but still I'm checking here to make sure that it is. If it's a NuGet catalog trigger attribute, then we are going to set up a storage account, create a Cloud Blob client so we can write that cursor into blob storage, set that up, make sure it exists, and then return a NuGet catalog trigger binding. This one is where our binding logic is finally going to start. So all of this until now is setup logic, making sure that it is recognized as a trigger binding in Azure Functions. But now let's look at how it works. This NuGet catalog trigger binding, what it does is it implements iTrigger binding, and this one will create a listener. Since we are creating a trigger binding, we have to listen for data somewhere. So what we are going to do is return a NuGet catalog listener, and that thing is actually going to provide the data for our binding. What this NuGet catalog trigger binding also has to do, or it doesn't have to do it, but it's always good practice to do this, is provide a binding data contract and a bind async methods. In Azure Functions, you can have multiple languages, so you can write your functions in Node.js, you can do them in Python, you can do them in PowerShell or C# or whatever. Bindings have to be written in C#. Now, if you are using, for example, a JavaScript-based function in Azure Functions, what you can still do is write your custom bindings in C#. And what we are doing here with that binding data contract and this bind async is really describing the shape of the object that the runtime will get from our binding. So if we would use a JavaScript-based function, by providing the fact that my data will have an ID property, version, etc., means that it knows how to treat the object, how to deserialize the object, and pass it into, for example, a JavaScript-based function. You don't have to do this when you are just doing C# and your bindings are all in the same project and so on, but it's always good practice because it describes what the shape of the data from your trigger will be. The NuGet catalog listener then is the thing that really has the logic for reading from the catalog and doing everything else. So what this catalog listener will do is essentially the same thing that we've been doing previously in that console application and in the timer function. This is going to set up a catalog processor using that cloud blob cursor to keep track of where we are in processing the catalog. It has that catalog client that uses an HTTP client, some logging infrastructure, etc. And what it's going to do is call back to package added and package deleted when packages are encountered. What our catalog listener is then going to do in that package added function is call executor.tryExecuteAsync with triggered function data. This is really where your function will get triggered. Our catalog listener will get a executor that it can call, and it calls it with a trigger value, namely a package add operation with the ID, version, publish date, package URL, fact that it's listed or not, etc. But this line of code is really going to invoke the function that we just wrote. So if we would run our entire pipeline here, let's maybe do that for a second, you will see that our catalog trigger is going to fire. And essentially it's going to write stuff to the output because it is going to run at this point. So let's do that and let's see what happens. Our functions are now running and you will see that packages should be flowing in very, very soon. There we go. So we are executing populate queue and table, which is our function, and this is being invoked by our custom NuGet catalog trigger binding, which is kind of cool. All right, not the most exciting demo if you just look at the output, but everything behind it is kind of interesting because we are now using that custom catalog listener and our function is now very, very nice and clean because we simply get that package operation and we can do something with it. So no longer all of that boilerplate code to make this function happen, right? Cool. So we now have a trigger binding. We are actually fetching data from the NuGet.org catalog and we are pushing it into an index queue and into a download queue. So we are really making progress. In fact, almost all of that left-hand side is done now. We have that function running and we have two queues that are being populated with the data that we have. Next thing we're gonna do is do that download package. And by the way, I'm gonna make a small remark here. You may be wondering why we have that watch catalog function that is watching the catalog and then pushing everything into a queue. The reason, and not indexing directly, the reason is because we first of all want to index and download the package, but second of all, because the NuGet.org catalog watcher is timestamp based, and it means that we can only have one function reading from that catalog, but still at some point we may want to fan out our solution and have multiple indexing functions and multiple downloading functions running at the same time. So that's why we are pushing stuff into a queue, and then those functions can run multiple functions based off of that queue. Anyway, let's download packages using that download queue. Right. Our downloading is actually fairly simple. So in our indexing itself, what we have been doing is from our catalog trigger, receive that package operation and then push it into a queue. Well, our downloads function is gonna consume that queue. It's gonna be triggered by something arriving on that download queue, and it gives me that same package operation. We are serializing the entire object from our initial binding through that queue, through this function, and we can now start working with it. What we are going to do with it is check if it's an add or a delete operation. If it's a delete, we are going to remove the package blob from storage. If it's an add, we are going to download the package URL and upload it to the package blob that we received from the function's runtime. So this is a very, very simple function. We get back the package operation. Using that, we either delete the package blob or we upload the binary that comes from the actual package itself. A small word of, small additional information here. Our blob, again, we did not have to set up a storage account. We did not have to set up a blob container and so on. No, our function simply receives a Cloud blob from the Azure Functions runtime. And the way we do that is by making use of this blob input binding. And that blob input binding will generate a name for that blob. We say that we want to be able to read and write to it, and then basically get that package blob that we can work with and upload contents to. So all of the boilerplate codes of setting up the storage account, making sure that we have a storage container that we can work with, and all of that is handled by this blob input binding. So our function can be nice and clean again and just do one thing and one thing well. Well, actually it's doing two things here, but again, one thing well, and one thing well meaning don't put the boilerplate code inside of your function. So downloading was fairly easy, and we are making progress again. Downloading is now done, and we can start with the next thing, which is indexing packages. Indexing is going to work the same thing. We have that catalog watcher pushing data into that index queue that we have, and then we will have a function to index packages. Before we dive into the function, let's think about how we are gonna index all of the types or all of the public types and public namespaces that are in that package. What we are going to do is we are going to make use of the system.reflection.metadata package to reflect on our assemblies and see which public types are in there. If we would use standard reflection assembly.load, for example, we would be messing up our entire function's runtime process. We don't want to load external assemblies into our process. No, what we want to do is download the assemblies, look at their metadata to figure out what the NuGet or what the public types are that are in there, and then do something with that. And that's what you can do with the system.reflection.metadata package. You can essentially read from the PE header in that assembly, and that PE header is basically all of the metadata that the .NET runtime uses itself. Next thing we are going to do after cracking open that package and reading all of the assemblies in there is store the relation between the package ID and the version plus the public namespace and public type, and we are going to do that in Azure Search. Could be a database, could be Redis, could be whatever data store you want. But in this case, since we'll be searching, we are going to make use of Azure Search there. Right, let's index our packages. Our indexing function, and I'm going to close everything else here. Our indexing function, what it's going to do is when we create our package indexer function, first of all, we want to make sure that we have the search index in Azure Search created. So that's what we are doing here. And the interesting thing there is that we are also building fields for a type called package documents. Let's make a quick sidestep to Azure Search. In Azure Search, you will have a service that you can call. You will have multiple or at least one index in there and an index containing package documents in this case. Package documents are what we are storing in the index that we are creating or using, and they will contain all of the metadata for the package that we want to store in there. So what we are doing is we are going to store the package ID, package version, package title. We are going to store the summary, authors, tags, icon URL, etc., because all of that data is something that we want to return to ReSharper when we do this find type on NuGet.org. Now, interesting in this package document, in the shape of what our index is going to look like, is that we also have to annotate it with what the field should be doing. So for example, we want to be able to search by package ID. We want to be able to sort by package ID. We want to be able to group or facet by package ID. And we also want to make this field retrievable. This is very important to annotate all of those properties the first time well, because you cannot really change it afterwards, except with reindexing whatever you have in the Azure search index. So package ID is something that we want to return in the API, something that we want to show at some point in the API and in the UI of ReSharper. So that means that we also should make package ID retrievable, because otherwise it's just going to be searchable, but making it searchable is using internal data storage in that index. If you want to get the actual value at some point, we have to make it retrievable as well. Some fields we don't want to be using them for search. For example, license URL, we don't want that as a search thing, but we still want to be able to retrieve it, so we want to store it in the index as well. Right, so that's our package documents, and in our function, what we are doing is making sure that our index exists using the fields from that package document type. Right, with that out of the way, what we are going to do is read from our indexing queue, and that's going to trigger this function to run. Again, what we get is a package operation, and using that package operation, we can start doing things. What we are going to do is run add package async. And what this thing is going to do is it's going to download the package from NuGet.org. It's going to save it to a temporary file stream. Azure Functions are serverless, but they still have a server somewhere. So if we would download a package that is 500 megabytes in size into memory, that means that our server is using 500 megabytes of memory, and there's a big chance that it will crash because there may be multiple functions running on that server and we are exhausting memory. So that's why we are storing the package to a temporary file stream on disk, so we can read from disk and not exhaust the memory on our Azure serverless server. When we have the package downloaded, we will open it using a package archive reader, and that's essentially a wrapper around a zip file, because NuGet packages are really zip files. And in there, we fetch all of the metadata. So using the NuSpec reader in there, we can get the package ID, title, authors, tags, icon URL, etc., etc. Next thing we are going to do is for every framework specification in a package, because a package can target both .NET Classic as well as .NET Core, for example, or Net Standards 1 and Net Standard 3, something like that. So for all of those frameworks, what we are going to do is loop them, and for every framework, find the assemblies in the package. When we find an assembly, we are going to again store the assembly to a temporary file stream on disk, and then make use of the PE reader from that systems.reflection.metadata NuGet package that we are using. Using that one, what we can do is loop all of the type definitions in there, make sure they are public, and if they are public, we can fetch the string from the header table for the namespace, and we can fetch the string for the type name as well. And if none of them have these weird, funky generated type names and so on, we will add them to the types that we are indexing. At the end of all this, we are building a new index action for the package to index, and that package to index is going to be that package document that we had before. Our add function is then going to return those things, and let me remove this line there. It's going to return all of those things as index actions, and then for every index action, what we will do is reach out to Azure Search, create a new indexing batch, and index whatever you want to index. If that fails, we are going to loop the results and the errors and make sure that we can figure out what went wrong doing all of this. Now, again, this is probably not the way to go, because if we return to slides, if you remember, do one thing well. Our function shouldn't really care about creating that search index. Our function shouldn't really care about search returning errors and retrying things, etc. No. Ideally, we would have a custom output binding to simply retrieve the packages that we want to index and have Azure Functions push them in search using that output binding. If you're interested, this talk is only 50 minutes, so I will have to skip to the next thing. But if you're interested in how that binding works, I have a big blog post on my blog that you can find on the URL that you see on screen. If you go there, you will find the full implementation with also how you could build a custom output binding for Azure Search. All right, let's continue. We're almost there. We have the search index working. We have things that are sitting in Azure Search. The next thing we want to do is build that API that ReSharper and Rider are going to be using. And we can do that using, for example, an HTTP triggered function in Azure Functions. So let's have a look at that. and what our web API is going to look like. Our API is going to be a function or a function class in which I have two functions, namely findType API async and findNamespace async. The reason is that there are two APIs that ReSharper uses, findType and findNamespace, but their signature is pretty much the same. The only thing that is different is the way they do the actual search underneath. So that's why I'm looping them both into run internal async and basically providing it with the name of the thing that it should be searching for. So it's either going to be the name as a type name, or it's going to be, in this case, the namespace that we search for. What this thing is going to do is it's going to check the API, fetch all of the parameters that are needed and so on. And based on the input, we are going to create the search text. The search text is going to be the query that we provide to Azure Search to retrieve the data that we want to display in the end in the UI. So what this is going to do is if we are searching for the type name, we will search for type name being .typename, which means if you are searching for JObject, which may be in the namespace newtonsoft.json, the full type name is going to be newtonsoft.json.jobject. If we search for .jobject at the end of the entire type name, we know that we are searching for a type. For namespaces, we do the opposite. There we search for example, newtonsoft.json. So we are searching for a partial namespace match there in our type names. Next thing we do is, of course, get that index client, loop the documents that we get back from search, and using that we start building the results using the API that ReSharper and Rider both expect in the UI. I'm not going to go through this because it's really specific how the API looks like, but suffice to say it works. And if we go to the API and search for example, JSON converts, we will get back a result from our search service that says, look, I have found several packages that match. Actually, it's only one in this case. The author is James Newton King. Description is this, download count, ID of the package is in there, but also the assemblies where this type can be found, or namespaces, and the platforms that are supported by this package, and the type names that I'm searching for. So I was searching for JSON converts, and that one is in there. Cool thing is, if I now run ReSharper in internal mode, what I can do is, for example, say var obj equals new JObject. This type is not yet referenced, so what I can do is Alt-Enter, find this type on NuGet.org, and you will see that right now my API is returning JSON.net, and I can now install it straight from within ReSharper or Rider if I would be using it. By the way, if you want to reproduce this thing, there's this NuGet browser in ReSharper, and if you run devenv/resharper.internal, which enables ReSharper's internal modes, what you will then see is that there's this test server URL that you can specify, and in here I specified that I'm now searching the indexer that I wrote to fetch the packages in there. Right, so that's pretty much it. It now works, and again, if I find this type on NuGet.org and then install that type, I can do that. Then ReSharper will all of a sudden make sure that all of this starts to work. At some point, yes, it's now installed, so we can import and be done with it and start using it. Awesome. I think we're almost there, and actually we are done. We now have the entire pipeline of fetching data from that NuGet.org catalog and then storing it in a search index for further reference. We have functions that collect changes in that catalog. We have a function to download the packages just because we want to have a download as well. We have an indexer that reads the PE header from the assemblies and stores the public types and namespaces in search. And we have an API that uses that search index to make things available. Remember, we created a trigger binding. There's also input and output bindings that you can use to simplify your functions and have your function do only one thing instead of having to do all of the boilerplate code as well. All of our functions can scale and fail independently. So for example, if the catalog watcher fails, the API still works. If the API fails, the catalog watcher still works, etc., etc. A full index back in May 2019 took almost 12 hours on 2 B1 machines. I also ran the index over the last weekend, and it took close to 14 hours now. But back in May 2019, we found that the NuGet.org homepage was lying. It said there's 1.7 million packages in NuGet, where we found the catalog to contain 2.1 million packages. There were 8,400 catalog leaves in the catalog with close to, pages with close to 4.2 million catalog leaves, which makes sense because NuGet essentially updated all of the packages. So 4,200,000 is roughly twice 2.1 million packages in the catalog. So it makes sense with that repository signing. And the last time I checked the storage accounts in January this year, I found 2.6 million packages, good for 3.5 terabytes of data. Some closing thoughts before I end and wrap up this presentation. If we were to deploy this to production, we would probably deploy every separate function in a different function app for costs and for failure. For cost, because our catalog watcher is using that custom trigger binding and has to run 24/7, we would run that in a B1, very simple, cheap instance, but a reserved instance and a always on instance because it always has to run. So that would be there. All of the other things would be in separate functions and consumption plans as well. Because the API, there could be moments during the day where the API is not being used. There could be moments where there's no indexing to be done. So all of those things can be consumption based on the queues that are providing data that have to be consumed by the function. Also for failure, if the catalog watcher fails and that VM goes down, for example, because we did something wrong with storing files on disk, we don't want the API to fail. The API should still fail. It may then serve some outdated data that is not super recent, but still the API works, and for most users, it's going to be more than sufficient to have that up at least. So we would deploy separately for failure as well. One last word on bindings. Are bindings portable? Yes and no. They are portable to web jobs, for example, if you have your own Docker container running web jobs. If you want them to be ported to, for example, AWS Lambda or OpenFaaS or whatever, they are not portable. So if that matters to you, I would not use bindings. If you know that you are going to stick with Azure Functions, either on Azure Functions or using web jobs in Docker, go for it because they are really nice to write and they make your functions super, super clean, and it's a really nice programming model. So don't be afraid of writing your own bindings when they make sense in your application. Again, full blog post with the full story and implementation of everything that I showed in this talk is on my blog. With that, thank you for watching, and if you have any questions, feel free to leave them in the comments and I will respond to them if possible. Thanks.